On the other hand, when water is injected in the inside the extruder, so we show bigger particle size than this process method, but we improve the conversion rate, the conversion of the final nanocomposite material. So, in fact, this figure shows the variation of conversion percent at the exit of the die for sample without second treatment, for sample with second treatment in water, and the green one is for sample with water injection. So the conversion here is the conversion. I mean, conversion is the amount of titanium particles generated from titanium precursor. Whereas to compare classical way to in-situ method, here we present the morphology of the sample prepared by mixing polypropylene with commercial titanium dioxide. We show an agglomerate of elementary particles whose dimension range from few hundred nanometers to about 1 micrometer. And for rheological behavior, we don't observe a modification for samples prepared with 3 weight percent of filled with 3 weight percent of titanium dioxide, and also with 9 weight percent of titanium dioxide. So third part of this presentation deals with the modeling of the extrusion process. So to model the process, we need data concerning screw and die profile. We need data also concerning material properties. We need data concerning process parameters, different screw speed, feed rate, etc. And we need data concerning the kinetic data made on squalane medium, on model medium. And then pressure, temperature, resistance time, also conversion rate can be modeled. For example, here we model the conversion rate at different positions in the extruder as function of feed rate. So we remarked that when feed rate increases, conversion rate decreases. So these results can be explained by this figure. So here we present the variation of resistance time as function of feed rate. So we note that when feed rate increases, the resistance time decrease, and we know that conversion is related to the reductional time, and then we can extend this behavior. Here also we present the conversion as function of different process parameters, as function of screw speed, feed rate, and different percent of precursor injected. To summarize, when percent of precursor increase, feed rate increase, and screw speed decrease, conversion rate decrease, and vice versa. So to interpret this results, are two factors: residence time and H factor. H is the initial hydrolysis ratio. And to finish, here we compare calculated conversion rate using Ludovic software and experimental conversion rate using TGE GCMS technique. So we remarked that for 10 and 20 weight percent of precursor injected, the model is operational, but with higher amount of precursor injected, the model is not valid. We suppose that this variation is due to the homogeneity of polypropylene titanium system with high amount of precursor injected. We change the material parameters such as viscosity and also shear, and Ludovic software suppose that all these parameters are constant during the process. And as conclusion, so we can prepare nanocomposite with via in situ synthesis of inorganic particles. We enhance the conversion rate by injecting water inside the extruder, but we have a balance between conversion rate and the morphology. The model is successful lower than 20 weight % of precursor injected, and as perspective, the role of the NCT polypropylene titanium dioxide nanocomposite on antibacterial property and the characterization of polypropylene matrix and the filler are under investigation. Thank you for your attention.
Questions?
I have a few short questions. The first one is in which conditions the water is added to the extruder? And the second one is have you seen any variation of the properties of this material when you add water? Any change?
Yes. I said that the morphology is totally different when we add water. We increase the size of titanium particles compared to. Sorry.
Another property, for example, mechanical or thermal properties.
We didn't check, but we increase the size, and we increase also the conversion from precursor to own particles. And for your first question, we add water by using hydrostatic pump by pressure, and it.
Hot water or hot water?
Not hot water. We inject the water inside the extruder, but extruder is at 200 degrees Celsius, and it works.
Yes, another question?
H. You say to us H is the
Yeah.
between the concentration of the precursor and the water.
Yeah.
H is equal here to 1 for the range of H. What is the range of H?
The H factor is not measured because we inject water. It's a feed rate also for water and precursor. So it's a continuous mechanism.
You don't calculate H.
No. It's small. So our precursor is very active. Without water, it's work. We can obtain nanoparticles.
Without water?
Yes, for this.
But
Yes. This figure shows the morphology of sample without water. The small amount of water inside the extruder absorbed on the polypropylene pellet can it's enough to carry out hydrolysis condensation reactions, because as I said, this precursor is very active, so small amount humidity also it's work with humidity without water.
what I mean, you said hydrolysis, so you must put water to form the surface reaction in hydrolysis and not affect condensation.
I said a small amount of water also with humidity it's work.